we were focusing on NBMA
Mm-hmm.
and OSPF.
Yes.
For NBMA, I have frame relay configured already on this
Mm-hmm.
serial interfaces.
Mm-hmm.
And now if you check the router one, show IP OSPF interface brief. There is no OSPF. Show IP interface brief. Okay, I don't have IP address on loopback. Let us put interface loopback 0. IP address 1.1.1.1. This is the network I'm going to use for testing.
Yeah.
And show IP protocol. I don't have any routing protocol. We are going to enable OSPF.
Mm-hmm.
All right. And likewise, let me also go to router 3. Interface loopback 0 IP address will be 3.3.3.3. And let's check show IP interface brief. Okay. So one more router to go. Interface show, no. Interface loopback 0 IP address is 4. And to check the interface status, show IP interface brief. We have it. And now let us check the frame relay. Show frame relay map. We do have a frame relay map. If you see here, to go to 10.0.0.1, the Del C number is this. So I'm pinging now 10.0.0.1, which is the hub route. Let me try pinging the other spokes. What is the other spokes? 10.0.0.
10.0.0.2. Sorry, 3 and 4.
3. I'm in 4. I'm in router 4. And I'm not able to ping 10.0.0.3 because we don't have PVC between these two. This is not full meshed. This is partially meshed. Sorry, this is hub and spoke. If R4 need to go to R3, it has to go to R1. Right. So when I try pinging 10.0.0.3, I'm not able to ping. You know, the reason why is we don't have a map. You see, the map is only for 10.0.0.1.
Yeah.
So I need to write a static frame relay map saying you go to hub. How to write this? This is how we write. Go to the interface serial 1/0 and say frame relay map.
Yeah.
IP is the protocol. Frame relay map. Yeah, IP is the protocol. And to go to 10.0.0.3, the Del C number that I need to take is same 401. If I take 401, I'll go to R1, right?
Yeah, correct.
And then use the keyword broadcast. Likewise, on R3 also. Okay, before going to R3, I want to show you map command. See, this is statically written by me, isn't it? Yeah. Earlier, we had this only to go to 10.0.0.1. But now I have written for 10.0.0.3. But still, why I'm not able to ping? Because for the return traffic, router 3 also need to know how to go to 10.0.0.4. So I'll go to router 3, show frame relay map. There is no map to reach 10.0.0.4. So go to interface serial 1/0 and say frame relay map for IP network to go to 10.0.0.4. Take the Del C number 301 broadcast.
Yeah.
That's all. Now if you check the map, show frame relay map, you see the static frame relay map. Now if I ping 10.0.0.4, I'm pinging. You see? Now you can ping the other spokes and you can ping the hub from both the spokes. Earlier this was not pinging, but now it is pinging. Now this topology is ready for OSPF NBMA network type testing. Right. So now I'm going to enable OSPF on all three routers first. And now you see the command is config t interface range loopback 0 and serial 1/0. It's not working.
I think it won't work.
So no problem. IP OSPF1 area 0. Interface serial 1/0, same command. Let us put the same command on other two routers. Interface loopback 0, IP OSPF1 area 0. Interface is serial 1/0. Oh no. Okay, no problem. I'm going to now configure R4 with OSPF. You can follow what I'm doing now, sir. Do you follow? Okay.
Yeah.
Now, OSPF neighborship will not come. Why? Let me show you why. Show IP OSPF interface serial 1/0. Now, if you notice, the hello timer is 30 and 120. Usually in OSPF, what is the hello timer? 10 and 40
seconds and 40.
But this is 30 and 120. The reason is on the frame relay interface, the network type by default is non-broadcast. When it is non-broadcast, neighbors are not discovered dynamically. Not discovered dynamically. That is why you don't see neighbor. There is no neighbor. So we have to configure neighbor statically. Router OSPF 1, neighbor 10.0.0.3. Neighbor 10.0.0.4. After you say this, the hello packets will be sent to this address. This address are reachable by this router, isn't it? It is reachable. So, because it is reachable, it can send the hello packets. But the problem...
So, for network type is non-broadcast for frame relay. So, that we cannot change.
That is the second scenario. First scenario, if you cannot change, if you are not ready to change, you have to manually configure neighbor statically. See, that's what I'm doing. Router OSPF 1, neighbor 10.0.0.1. Likewise, you go to router 4 also. See, it says neighbor has come, but you have to do it on either side. We did on only R1. That's not enough. Neighbor is 10.0.0. Okay. Now, if you check the routing table on R1, show IP route OSPF, you are seeing the route from router 3. Why it is not coming from router 4? Okay, it has come. So I'll be able to ping from here to the LAN side of router 3. That is 3333.
Perfect.
See, there will be a DR-BDR election. Show IP OSPF neighbor. There is a DR-BDR election. What if the hub goes down? There is no use of DR-BDR. This is only best for full mesh. But do we have full mesh? No. That's why we go to next method, which is point to multi-point. The first type is non-broadcast. It is over. Do you have any question? Non-broadcast timer is 30 and 120. Correct? In non-broadcast, there will be DR-BDR election. Correct? We saw no. There is DR-BDR, no?
Why?
Why you are asking? In non-broadcast, there is DR-BDR election. Yes or no? You
Yes,
got
yes, correct.
confused. Okay.
Hmm.
Hmm.
No, sir, actually, one question like, but we configure static neighbors.
Of
So
course
in
they
that
will.
case,
They
whether
will
it will be
compare the
having
router ID
DRBDR
and they will
selected.
select DRBDR. You go back
Got
to
it.
the
Okay.
video and see, I have said that there will be DRBDR election. Neighbors need to be
Yeah.
manually configured. Okay,
Yes.
now
Okay. I
next
forgot.
is,
Sorry.
and it is recommended only for full mesh, but we don't have
Mhm.
full mesh. The last point about
Full
non-broadcast
mesh.
we
Yeah.
learned is the neighbor need to be in same subnet. Are they all in same subnet? Three routers, all three are in 10 network, isn't it? So,
Same
are you
network. Yeah.
comfortable with the first one, non-broadcast? Next one is point to multi-point. So
Yeah, I'm
I'm going to
comfortable.
remove the neighbor list, which I configured. I'm going to remove this neighbor
Mm-hmm.
because we are going to next network type.
Mm-hmm.
Yeah,
So we remove
because
the
we are going
neighbors,
to move
correct?
to the next method. In next method,
Okay.
neighbors will be dynamically discovered. So I want to remove this. I want you to see that the neighbors are dynamically
Mm-hmm.
discovered.
Mm-hmm.
Now, if you go and check, there won't be a neighbor. Let's go and check. Show IP OSPF neighbor. You see? Wait. Sometime it will go.
Mm-hmm.
Show run section router OSPF. I removed neighbor, but still the neighbor. It will go. Give some time. Clear IP OSPF process. Yeah, I removed neighbor. Show IP OSPF neighbor. Clear IP OSPF process. Okay. Okay, neighbor is gone. Anyway, let's wait for a few minutes, otherwise.
Mm-hmm.
Okay, good. There is no neighbor anywhere. Okay. So the default network type is in a frame relay interface. When you enable OSPF, what is the default network type? Correct. One more time, I would like to show you.
Non-broadcast.
It's non-broadcast. I'm going to
Mm-hmm.
change this as point to multi-point.
Mm.
Right. So what I do is I shut down
Mm.
the interface. That's a good practice. And then I say IP OSPF network type
Mm-hmm.
point to multi-point. This is the command.
Mm-hmm.
Now we are changing from non-broadcast to
Yeah.
point to multi-point. Let us also go to router 3.
Mm.
Okay. Now what is next is I have to say no shutdown.
Now we have to
When I say no shutdown,
run back.
what are the things we expect?
Yeah. Right.
We expect dynamic discovery of neighbor, correct?
Mm-hmm.
Second, we expect no DR-BDR
Neighbors.
election.
Yes.
There should not be DR-BDR. They should have full relationship with
Okay.
all neighbors. There will not be
Yeah.
any DR-BDR.
Mm-hmm.
Okay. And other things are same. Timer is same. All should be
Mm-hmm.
in same subnet.
Mm-hmm.
All these are same. Timer is 30 and 120.
Mm-hmm.
Shall we do? No shutdown. No shutdown. No shutdown. No
Yeah,
shutdown.
sure. No shutdown.
You see, the interface has come up and I'm expecting two neighbor dynamically discovered. I'm waiting. I'm waiting for that.
Mm-hmm.
It will come. 100%. Meanwhile, see, it has come. With one neighbor, it has come. Meanwhile, let us go to the interface show IP OSPF interface serial 1/0 and see the timer. Timer is same 30 and 120, and it
Mm-hmm.
is okay.
Mm-hmm.
Show IP OSPF
Point to
neighbor.
multi-point. Yeah.
You see both the neighbors, and wait a minute, it is in init state. It'll soon promote
Mm.
itself to two-way and start exchange and full state.
Yeah.
Let's go to router 4. Oh, this is still not forming neighbor. Show IP interface brief. Did I say no shutdown? Yes.
Mm-hmm.
0, I'll just shut down once
Up only, no?
and say no shutdown. I'm just resetting the OSPF. Shutting down.
Mm-hmm.
See, this is called as point to multi-point, P2MP. And I'm expecting
Multi-point. Yeah. Mm-hmm.
Mhm. Okay, see, it has come. Full state. See, there is no DRBDR. There is no DRBDR.
Mm.
If you have DR other, then it will be in two-way state. It is in full
Yeah.
state. Yeah. Okay, let's check the routing table now. Show IP route OSPF.
Mm-hmm.
And now you can ping. Yeah. Okay. Neighbors are dynamically discovered, and it is well suited for full mesh.
Mm-hmm.
Sorry,
Yeah.
any topology. Even hub and spoke. See, this is hub and spoke, no? It's even good for hub and spoke. You see? Even
Yeah,
in
correct.
R4, I'm able to see the other spokes.
Yes.
And I'm able to ping.
Mm-hmm.
Do I have direct connection between R3 and R4?
Mm-hmm.
It is always through hub, no? We don't have PVC, we don't have frame relay. But
No.
still, you are able to ping. How?
Yes, correct.
In order to go to 3.3.3.3, the routing table
Mm.
says you should go to router
Mm.
1. From there, it gets routed. You see?
Mm. Yeah. Correct.
Of course,
So
because
in
there is
order to
no
go,
OSPF
this
in the
is
middle.
R4.
The
So to
middle
reach
one is frame
R4 to
relay only
R3, he has
router.
to go through R1, right?
It's a frame relay only router. Do you have any routing in the middle router? R2.
Mm-hmm. Yeah.
It's frame relay only router.
No.
All right. Now next is
Mm-hmm.
we're going to again shut down those interfaces and switch to the third mode. These two modes that you have seen just now is what you will see in all vendor. This two is what RFC standard. The other three that we are going to see is Cisco proprietary.
Mm-hmm.
You got it, sir? And
Mm-hmm. Yeah.
all vendors.
So these
Yes.
two, like non-broadcast and
Yes.
P2MP, these are two standard which is all available in all the vendors, and other three are for Cisco. Right?
Okay. So we have shut down those interfaces. We have removed that point to multi-point command. And we are getting into the third mode. What is the third mode?
Mm-hmm.
You don't remember? Let me write down here for you. The first one is non-broadcast.
No, sir, I'm not. Yeah.
The second one is point to
Yes.
multi-point. The third one is
Mm-hmm.
the combination of the first and second. Point to multi-point, non-broadcast. You understood? It's a combination of both. The fourth one is broadcast.
Yeah.
The fifth one is
Combination
point to
both.
point.
Yeah.
We have seen the first two. We are now into the third one. The first two are RFC standard. This third
Mm-hmm.
is Cisco.
Mm-hmm. Mm-hmm.
Yes, sir. Now let us go to the third one. Point to multi-point non-broadcast. Point to multi-point non-broadcast. Now, the best of first two is put together. What is the best of first
Yeah.
one? There,
Mm-hmm.
there is no dynamic discovery of neighbor. That's the best. Why, you know? Because in the
There is
middle you have a
no
frame-relay cloud.
dynamic
Usually the frame-relay cloud is an untrusted internet.
yes.
So when you form neighbor dynamically, then there is no
Mm.
security.
Correct.
And what is the best of second one?
Mm-hmm.
No DRBDR. If
Yeah.
there is no DRBDR, what is the good thing in that? The good thing is,
Mm.
and there is no DRBDR, what is the good thing? The good thing is, it will suit to any topology, isn't it? Hub and spoke or full mesh or any topology, any network design. Okay. Now
Okay.
I'm going to
Yeah.
R1. And interface serial
Yeah.
1/0. I'm going to say IP OSPF network type point to multi-point, again non-broadcast. You see, both things together. Let us configure on the other routers and then I'll say no shutdown. Is that okay, sir?
Yeah.
IP OSPF network type point to multi-point non-broadcast.
Yes.
IP OSPF network type point to multi-point followed by non-broadcast. Now let me say no shutdown here, here, and also here. Will the neighbor come? No. Neighbor will not come. Now, I want to show you the output on the interface, show IP OSPF interface. Usually when we see here, it will show you the full network type. But here, even though it is point to multipoint non-broadcast, it shows only point to multipoint. That is how Cisco has designed it. But it is actually point to multipoint non-broadcast. Where can I see that? You can see that here. Show IP protocol. These are the two.
Non-broadcast.
Yes. Show run interface.
So this is these are available in NXOS also, like N9K switches.
Yeah, you can see this point to multipoint non-broadcast. The neighbors will not come automatically. Show IP OSPF neighbor, they never come. Yeah. So let's configure. How do you configure? Router OSPF 1 neighbor.
You have to statically configure. Right?
Likewise, we go to router 3. Now it will start negotiating with 10.0.0.1 and you will see neighbor coming shortly. Fallen down. Sorry.
Yeah.
Okay. Now, why the neighbor is taking too long? It will come. It has to negotiate by doing unicast. That's why it takes time. Okay, you see the neighbor with router 4 is ready. And with router 3 is also ready. All right. So good news is there won't be DRBDR. Show IP OSPF neighbor. See, full relationship. No DRBDR. Now, let us go and again shut down these interfaces and remove this.
Yeah, correct.
Okay. Now what else I have to remove is the neighbor statement. You remember I gave neighbor. I need to remove that neighbor which I configured manually.
Yeah. Yeah.
Okay. What's the next method? Next one, broadcast. Is this a broadcast environment? No, is it a broadcast environment? Come on, sir. You got NBMA, non-broadcast. You got frame relay. In frame relay, what is the timer for OSPF? In non-broadcast, what is the timer?
Yeah, broadcast.
But if you want to have an experience of broadcast in a non-broadcast environment,
30.
then you need this. Again, let me repeat. this is not really practically needed in the real world. This last two which we are going to see is useless. Why? In a frame relay environment, if you want to have a broadcast experience, you can use this. In a frame relay environment, if you want the neighbor to be dynamically discovered, if you want the timer to be 10 and 40, and if you want DRBDR, all these three are what? Broadcast, no? Normally we used to have in a broadcast environment. If you want to have a broadcast experience in a non-broadcast frame relay environment, you need this. You got it?
Broadcasting.
So let me go to router 1 and now try to go inside serial 1/0 IP OSPF network type. I say broadcast. In reality, it is not broadcast, but I'm saying no, consider as a broadcast and behave like a broadcast. So let me also say in the other two before I say no shutdown. Jesus.
Broadcast, okay.
Sorry. Yep. Broadcast. So only thing that no shutdown. Yeah. Are you ready? No shutdown. No shutdown. No shutdown. Now you will see neighbor coming up automatically, dynamically, and the DRBDR election will be there. The timer will be 10 and 40. Even though it's a non-broadcast environment, you will have a broadcast experience. Show IP OSPF neighbor. It's going to come. It needs to negotiate, that's why it takes time. Now, meanwhile, I'll take you to the interface and show you. Show IP OSPF interface brief. Show IP OSPF interface serial 1/0. You see, even though it is a non-broadcast environment, the network type is broadcast. So the timer is 10 and 40. There will be a DRBDR election. You understood? Show IP OSPF neighbor. I see. No, that's what I'm saying now. In NBMA time, you don't have NBMA now. In NBMA time, if you want the OSPF to
what is the benefit actually to have this broadcast?
DRBDR and timer as 10 and 40, then you need this.
Yeah.
It's in an init state. It will come quickly, so it will take few minutes. It has to negotiate because it's a frame relay in the middle. It needs to go through the tunnel VPN, so it takes time. Now you see it is loaded to full. You see there will be a DRBDR election, and I showed you the timer and so on. Point to point is needed if you have sub interface here and R3 in one network, R4 in another network. In that case, so we will not be doing that. So it's not needed. Only in NBMA situation you will need that. Even this one which I did now broadcast is not needed. Now, why have you learned this when you don't have NBMA? What do you have today? You have broadcast. Ethernet broadcast. Now in broadcast, if you want to have non-broadcast experience, what you will do? You'll go under the interface and say IP OSPF network type non-broadcast.
Ethernet, yeah.
And you now know how it will behave. It will not form neighbor dynamically. It will not. So the timer is 40 and 30 and 120. You know, if you want such experience in an Ethernet
On
environment,
broadcast, yeah.
you enable the first one.
Mm.
Second one, you want dynamic discovery, but you do not want DRBDR. Then you do go with the second one. In Ethernet environment, if you want point to point, you can go and say point to point.
Got it.
In point to point, will there be DRBDR? No. In Ethernet environment, there will be DRBDR. But if you say, no, I don't want DRBDR, then you can go and say point to point. All right. In coming classes, I'll be doing these things in an Ethernet environment. Then you will understand the reason why we learned this. Yeah. So in our next class, we need to do a lab on LSA types.
Point to point.
All right. So any question on what you have seen today?
Yes, correct. Yes.
Please. Network types.
Yeah, correct. Yeah, let me summarize, sir, actually, what I understood. So basically, we are learning the NBMA. It was like, network types, no? Like now it is not there, but earlier times it was there. And we are configuring this frame relay thing. So that also an older technology. And the frame relay, it creates these tunnels, right? So in between, so we selected this hub and spoke configuration, and we prepared the tunnels, and on top of the tunnel, we are enabling this OSPF protocol.
Yes. So you can have this
NBMA
experience in a Ethernet environment. That's why we have learned it. We'll do and see in coming days. But before that, we need to finish LSA type labs.
That's what we see
in that also. If it is possible, I'll try to implement this one in that also. Fine, sir. See you in next class.
Yeah. Right.